Hello everyone, I welcome you all in the next lecture of 12th class NCERT Mathematics. In this video lecture, we will discuss question number 19, 20 and 21 of exercise 5.1. We already know that thing because we solved up to 18 questions that this complete exercise is based on the continuity, discontinuity or like that. That they are saying that show that the function is discontinuous, show that the function is continuous, check its continuity, discontinuity. So this complete exercise is completely based on the definition of the continuity and its algebra of continuity and algebra of limits also. So without further ado, let's get started. Our question number 19, what it says, we'll do. Show that the function defined by g of x equals to x minus greatest integer of x. This is greatest integer of x actually, okay, and the symbol is greatest integer of x, okay. So is discontinuous at all the integral points. Integral points means they are saying that integer points, okay. Here they represent that the square bracket of x denote the greatest integer of x, okay, greater than or less than equal to x. So here observe that the function is given f of x equals to the x minus greatest integer of x, okay, and the domain of this function we can observe that it is for all x belongs to R. What is the domain of this function is? Domain of this function is complete R. Why so I am taking the complete R domain? Because observe that here the function is given x minus greatest integer of x. If you put any x here, if you put any x here, then for any real values it will provide always output, okay. For every input we are getting output, hence the domain of this function is complete R because it doesn't have any problem, okay. And also provide for every real number unique value. Corresponding to every real number we have a unique output also. For two things are there to being a function, that for each element it should provide a unique value. Second thing, that output also coming for each input. So here we have a same thing for complete R, and the domain of this function is complete R. Now you can observe that when we show this function is discontinuous at all the integer points, first of all we will see something. If you have any real number, for this real number we have, for writing this real number we have its two part. The first part is greatest integer of x, other part is fractional part of x, other part is its fractional part of x. Now how we are writing this thing? Because if you have, suppose x I am taking 5.37, I am taking for example, okay, this is just example, okay, x equal to 5.37. so it has two part, one part is 5, okay, other part is, the first part is 5, other part is 0.37. so basically the above number is written as 5 plus 0.37. so 5 its greatest integer part and the 0.37 its fractional part. So what actually they are giving, the our function is actually, as they are saying na here, x minus greatest integer of x. So here our function is x minus greatest integer of x can be written as fractional part of x. It is as fractional part of x, okay. So f of x basically fractional part of x. I hope you understand this thing. Now observe, this is our function, I assume it is star, okay. Now first of all we will draw the graph of this function, okay, and from that graph we can observe also that where it is discontinuous, where it is continuous. So here I'll draw the graph. Here you can see, here, yeah, here we have the graph of this function. Here maximum value is actually the range of this function is close 0, open 1, okay, it will never attain 1. So here at integer you will get 0 value, okay. Now if we have 2 here, again it will increase, okay, and at 2 we get 0 value. Like that we can draw the graph. If you have 3 here, then you observe that again at 3 we have 0 value, and in between it is increasing. Same as that for the minus 1, it's keep on value increasing, but at 0 it has value 0 here. Okay, now we have at minus 2 also it is increasing, and again its value at minus 1 is 0. Like that the graph will come. So observe first of all one thing, that what we need to observe here, that we need to observe one thing here. See, as suppose we are taking 1, at 1 we are checking the continuity of this function. Observe that when x approaches to the 1 from the left side, your fx approaches to 1. Okay, when x approaches to 1 from the left side, fx approaches to 1 also. Okay, when how we can write this thing? If x approaches to 1 from the left side, the notation, the meaning of this notation is, when x approaches to 1 from the left side, then fx approaches to 1 also. Okay, and if x approaches to 1 from the right side, then fx approaches to 0. That how we can write this thing? If x approaches to 1 from the right side, then where fx approaches to 0. So here we can observe that at 1 the limit is not exist. So if limit is not exist, then the function is not continuous. Same thing will happen for 2, 3 up to so on, and minus 1, minus 2, minus 3 up to so on, and 0. Understand? I think you understand this complete visualization, how we can go by the graph. Okay, so if you don't have a time in exam, you have a less time, then you can write this language for arbitrary integer, and then you can say simply, okay, for every integer left hand limit is 1 and right hand limit is 0 for every integer, and then figure. So here, as the integers are infinite, so we can't, it is not possible to check each integer. That we need to disprove for each integer that the function is discontinuous. So here what I will do that I will take a single integer. How we can take that single integer? Listen here. See here. Let a belongs to z. A is an integer. Okay. So for that integer we will find LHL. LHL is limit x tends to a negative f of x, limit h tends to 0 f of a minus h, and limit h tends to 0 f of a minus h means c. If we are taking hypothetical, suppose here hypothetical we assume a is here. Before that, which integer? A minus 1 integer, and after a is a plus 1 integer. So a minus h should be here and a plus h should be here. So first of all, as we are discussing a minus h, so we will discuss a minus h. A minus h is, because h is a very very infinitesimally small positive integer, so minus h become the infinitesimally negative integer. Okay, infinitesimally small negative integer. So here you can observe the graph will be like that, and here the graph will be like that. Okay, so if x is moving towards a from the left side, the way fx moves towards 1, but how we can find the value here? Here you can observe that a minus h fraction part value will be, what it will come? It will come as 1 only. It will come as 1 only. How it came 1 only? How it came 1 only? That if limit s tends to 0, then fractional part of a is, then what do we have? The fractional part of a, if you can observe that, what the meaning of this one? The meaning of this one is when h moves towards 0, where a minus h is moving, okay, it is moving towards 1. The meaning of this one is, because see, As h moving towards 0, it means h is continuously decreasing. So a minus h is moving towards the 1, moving towards the 1, that is the meaning. Okay, and what RHL will come? RHL will be limit x tends to a positive, f of x you have, limit h tends to 0, f of a plus h you have, limit h tends to 0, f of a plus h means fractional part of a plus h value, and what we will get? We will get 0 from here. Why so? Because if x is moving towards the a from the right hand side, fx is moving towards 0. So here we can observe that here how we can write as h moving towards 0, then the fractional part of a plus h is moving towards 0 also. Okay, so it implies that LHL at a LHL at a is not equal to RHL at a of f of x, of f of x. I hope you understand this thing. Okay, I hope you understand. So it implies that, what it implies, limit x tends to a, fx does not exist. So it implies f is not continuous at a. Clear? F is not continuous at a, and as a is any arbitrary real number, so as a is any arbitrary, not arbitrary integer, arbitrary integer, it implies for all a belongs to z, f of x is discontinuous. Okay, f of x is discontinuous. I hope you understand this thing, what I want to say here. Okay, now one more thing is there, that they are saying that we need to prove that at all the integers it is discontinuous. Okay, but here we prove that at integers it is discontinuous, but we need to also prove that except integers this function is continuous. So first, this is the first part where we prove that where we prove that the function is discontinuous at all the integers. But now we need to prove that this function is continuous at all the real numbers except integers. So here we need to, what we need to do here, observe that how we need to write that thing you need to prove. If you have any doubt, then you can tell me. R minus z. Okay, we need to take an element r minus z, and you can observe that LHL, RHL and f of a, all three are equal. All three will be equal. Suppose it is L1 will come, it is L2 will come, and this will be L3. Then guarantee LHL equal to RHL equal to f of a will come. Okay, and if it will come, so it we can implies that f is continuous at a. F is continuous at a. So like that we need to do for the non-integer points, because we need to prove that they are at integers, they are continuous. So I hope you understand this complete question, what we need to do. This is your B part which we need to do. This is your B part. Okay, so that's your homework. If you have any doubt in this one, I will make a separate video and I will add in. Okay, it will become a part 1 and that will become part 2 if you have any doubt in this one. Okay, then by the comments you can tell me. Now next question is the function defined by f of x equal to x square minus sin x plus 5 is continuous at x equal to pi. Okay, so how we can proceed? See, two ways are there. First one way is the first way to do the to question number 20 is you observe that the function is written as f of x equal to the, can we write it as x square plus 5 minus sin x. Okay, and domain of this complete function is complete R. Domain of this function is complete R. Okay, why? So because for complete R it is defined in general if I am saying. Okay, now you can observe that x square plus 5 is a polynomial. X square plus 5 is a polynomial and sin x is a trigonometric function, you already know. Okay, so and minus into sin x is that we can say it is algebra basically, because x square plus 5 is a one function which is continuous for all x belongs to R, and minus sin x is also continuous for all x belongs to R, hence their addition is also continuous for all x belongs to R. Okay, so if it is true that the function is continuous for all x belongs to R, then also it is continuous at pi, na? Because pi is also a real number. Okay, so how we can proceed in this one? You can see here. See here. I will draw the graph of x square plus 5. X square plus 5 is like that. Okay, this is your 0 comma 5. Okay, that's why it is continuous. For all x belongs to R, it is defined. It is defined, and hence we can draw the graph without lifting our pen. And what about the sin x? The sin x graph is like that. Like that we can draw the, yeah, like that we can draw sin x graph. Okay, so here it is also continuous for all x belongs to R, although its values in between 1, minus 1 and 1. Okay, so their addition and subtraction also continuous for all x belongs to R. Now this is the one way to prove that the function is continuous at x equal to pi. But the other way how we can prove that the function is continuous at x equal to pi, you can observe here. See here. I'll choose the pen different color. Now function is given f of x equals to, what do you have of x equal to? X square minus sin x. X square minus sin x plus 5. Okay, so obviously for the continuity, if we need to check continuity at x equal to pi, how we can check? We can check as LHL we need to find, RHL, LHL we need to find, RHL, and f of pi we need to find. Three things we need to find, and we need to check that are all the three things are equal or not equal. So first of all, LHL I need to find. LHL we will find. LHL is limit x tends to pi negative f of x, limit h tends to 0 f of pi minus h we have. Okay, so we need to find the value as the function is defined. So how we define? Pi minus h whole square minus sine pi minus h we have, and plus 5 we have. Okay, here we can observe that the value will be, we will get, first of all we need to simplify it. Okay, we have limit h tends to 0 limit h tends to 0, pi square plus h square minus 2 pi h a square plus b square minus 2ab. And here the trigonometric rule we can apply, sin h will come plus 5. Now if we apply limit here, we will get pi square plus 5 only. Okay, similarly in the similar fashion you can observe that, yeah, enough, yeah. Now LHL is there, you can assume this equation is first. Okay, now we need to find RHL. What is our RHL? RHL is limit x tends to pi positive f of x, limit h tends to 0 f of pi plus h, limit h tends to 0 pi plus h whole square minus sine pi plus h plus 5. If we solve again, limit h tends to 0 pi square plus h square plus 2 pi h, and sine of pi plus h is minus sine h, so it will be plus sine h plus 5. Okay, this one we will get. Now if you apply limit, we again get pi square plus 5, you will get, assume it is second equation. Okay, now the function value at 5 will be, the function value at pi will be pi square minus sine pi plus 5, and sine pi is 0, so it will be pi square plus 5 will come. Okay, that's your third equation. From first, second and third we observe that LHL equal to RHL. Here we will write from first, second and third equation, what we have, LHL equal to RHL equal to f of pi. If all three things are equal, then we say f is continuous at x equals to pi, at x equals to pi. I hope you understand. Okay, now we will move to our the next question. The question is 21st question. Okay, what they are saying, discuss the continuity of the following function, and you can observe that the function fx in a part, b, c part and b part, in all the three part, we observe that only two functions are using. Other one function is sin x, other function is cos of x. So how we can write the solution of this one? Actually algebra is given. Okay, again what is given? Algebra. Yeah, here you can observe that your, first of all I assume something. Okay, in a question number 21, what we have, g of x equal to sin x is there, and h of x equals to cos x is there. One function is g of x equal to sin x, other function is h of x equal to the cos x is given, and we have, you can observe that what is our a part? A part is basically f of x equal to the g of x plus h of x is there. Okay, and b part is f of x equal to the g of x minus h of x is there. Okay, and c part is f of x equal to g of x into h of x is there. What we have? H of x is there. So what we have in this, actually question number 21, sum of sin x and cos x, difference of sin x and cos x, and product of sin and cos x. So one way is to go by the actual definition, and we will do three parts. Okay, better way how we can proceed in this question, that fx is your sin x plus sin x and cos x. So I will write something about them, and then we will use algebra. So what we can say, that observe observe that observe that gx and h of x domain for the both the function, domain for both is R. Domain for both is complete R. So on complete R, gx and hx both are continuous, for all x belongs to R. Gx and hx both are continuous for all x belongs to R. How? Observe that your sin x is graph like that. So we can draw the graph of the sin x without lifting our pen. And what is cos x graph? Cos x graph is like that. Next time I will draw these graphs in a very neat and clean manner. For this time you can compensate. Okay, see here, you have gx equal to sin x, and you have cos x equal to the, this is your cos x graph, and this is your sin x graph. So both are continuous, so their addition is also continuous, their subtraction is also, their difference is also continuous, their product is also continuous for all x belongs to R, by using the algebra of the continuity of the function. Okay, like that you can prove this question. So I hope you understand all these three questions which I taught here. The first question is question number 19, which we completed. Okay, the main part we completed, second part you need to complete, which one is that for non-integers it is continuous. Okay, and question number 20 we completed in a full manner, and question number 21 is simply we can draw the graph, and simply we can draw graph of both functions, and we can say that gx and hx both are continuous for all x belongs to R. Hence their addition is also continuous for all x belongs to R, their difference is also continuous for all x belongs to R, and their product is also continuous for all x belongs to R. Why so? Because the sum because their sum sin x plus cos x domain is also R. Okay, because for each x it is defined, gx minus hx domain is also complete R. Okay, and product domain is also complete R. Hence by using the algebra of the continuity we can prove that simply the function is continuous for all x belongs to R. So I hope you understand this thing. If you have any doubt or any single query, then feel free to ask me in comments. Thank you for watching. Take care.